In the last class, we discussed about the Bohr's atomic model. Okay, so the Bohr's atomic model consists of a nucleus, of course. The electrons are revolving around the different paths, and those are called as what? Stationary path or an orbit. So when an electron present in an orbit, it is neither it gains an electricity energy nor loses an energy. When it is in the same path, the electron never loses its energy or gains its energy. Understood? So once it changes its path, either by losing or gaining an energy, again it comes to the original level. So the neutral, which one is the stable atom means where the electrons are in the lower energy state. So when the electrons are there in the lower energy state, then that atom is said to be a neutral atom, and it is a stable atom. That state is called as ground state. Okay. So the momentum of that electron spin. So you know the nucleus is there, electrons are going to revolve around the nucleus. So those are having angular momentum. mvr is equal to h divided by 2 pi. H is the Planck's constant, I told you. Okay. Next, the maximum number of electrons to be filled in the single shell is how much? 2n square. These are the postulates of Bohr's atomic model. Okay, so phi is enough, means electrons are revolving around the nucleus in a circular path. That path is called as orbit or a stationary path or shell. Understood? Next, so when the electron are in a particular shell or it is continuously moving with the revolving in the same shell, then it neither loses an energy nor gains an energy. Understood? So until it changes the shell, it never loses or gains an energy. That is the second postulate. Third one is around the nucleus. Of course, they are revolving in a circular manner. Means when they accelerated, their angular momentum becomes mvr is equal to nh divided by 2, where n is what? 1, 2, 3, 4, that is a number of spins and anything, natural number I can say. Understood? And the next one is, okay, so the spectra emitted by this, as I told you, that is equal to what? Hydrogen spectra. What I explained it before. Lyman series, Balmer series, Paschen, refund. So the energies absorbed are emitted by the electron of the outermost shell. And so here, this is the nucleus, and so many shells are there here. So the shell which is nearer to the nucleus, that is lower in energy. The shell which is far away, and valence, this one is called as valence shell. Last shell is called as valence shell. So valence means what? Completely last, means far away from the nucleus. One which is far away from the nucleus, that is having high energy. The shell which is nearer to the nucleus, that is having low energy. Understood? And so if the electrons are in their lower energy state, then only the atom is said to be stable, and that state is called as ground state. The number of electrons to be filled in a single shell is 2 is equal to n squared. N may be 1, 2, 3, 4, etc. Understood? So this is what Bohr's model. Postulates of Bohr's atomic model. So in today's class, I'll explain. As I told you, today we are using quantum mechanical model or quantum atomic model. So means the Bohr's atomic model also having some limitations. Okay, so that's why we are nowadays using quantum mechanical model or quantum atomic model in this. So in that, what is the limitations of? Very important for 3 marks. Limitations of Bohr's atomic model. So students remember, he considered what? Initially the real nature of the particles. One is the wave nature, another one is the particle nature. Second one is the spectra obtained by these equal to the spectra which is explained by hydrogen. Means he considered only single electron atoms like hydrogen, lithium, sodium, potassium, rubidium, cesium. These consist of only one electron in their outermost shell. When you write the electronic configuration, you get like this. And this is francium 7s2. Means in outermost shell only one electron is there. So this spectra, Bohr's atomic model, it successfully explains the single electron system, but it fails to explain multi-electron system. Understood? So the first limitation is there. It does not explain spectra for atoms with multi-electron. Means it successfully explained spectra for a single electron system, means hydrogen like atoms. But it fails to explain spectra for atoms with a multi-electron, means more than one. That is the first limitation. And second one is this theory cannot explain presence of multiple spectral lines. Okay, so in the line spectra I told you, individual lines are there like this. Individually they are explaining. So in the same cell, there may be a chance of multiple lines. So this spectra cannot explain the multiple spectral. Sorry, this what is the theory or Bohr's atomic model could not explain the presence of multiple spectral lines. Understood? You should write here could not explain. So I write only multiple, sorry, presence of multiple spectral lines. The next one is this theory could not explain splitting of spectral lines. Okay, this theory could not explain splitting, means separation of spectral lines. Okay. This theory fails to explain nature of matter. Okay, this theory fails to explain nature of matter, but this is explained by de Broglie equation. Remember here this point. So this Bohr's atomic model couldn't explain the nature of matter, but this nature of matter later explained by whom? De Broglie. That is called as de Broglie's equation. Just later I will say in the quantum mechanical model. Okay, remember this point. So you know the drawbacks and limitations of the initial theory is the leading point for the next theory. Are you getting? Limitations of the initial theory. So before Rutherford atomic model is there, in that he only explained alpha scattering, he didn't completely explain the spectral lines. So those limitations, he explained only particle nature, he cannot explain wave nature. By taking wave and particle nature, Bohr's explained this. So Rutherford limitations is the leading point for this Bohr's atomic model, and limitations of Bohr's atomic model is the leading point for the development of quantum mechanical model. Understood? Okay, so this is nature of matter. So that is explained by de Broglie. Later I will see. Okay. This theory could not explain uncertainty principle. Uncertainty principle. This is also remember. Due to these two, the next model is design. Due to these two reasons, the next model is design. Okay. Next, this model cannot explain. Could not explain shapes of orbitals. This model do not explain shapes of orbitals. The last one, it does not explain chemical bonding or cause of chemical bonding. Understood? Listen. So initially it does not explain the spectra for atoms with the multi-electron. If more than one electron is there, this Bohr's atomic model cannot explain the spectra. It's different lines. Okay. Next. So it also cannot explain the presence of multiple spectral lines. If two or more electrons are there, then two or more lines is also there. It couldn't explain. It explains only one line spectra, single line spectra. Next, this theory could not explain splitting of spectral lines. Splitting means separation. Understood? Next, this theory fails to explain nature of matter, uncertainty principle, shapes of orbital, and the chemical bonding. So these four reasons, shapes of bonding, are successfully explained by what? Quantum mechanical model. So that is the last model and presently what we are using. Understood? So now towards quantum atomic model, what are the leading points? Quantum mechanical model often quantum mechanical model often. So students, the leading points to the quantum mechanical model is, first one is dual behavior of matter. Dual behavior of matter. As I told you, the nature of matter. So that is dual behavior. One is wave, another one is particle. That is initially explained by whom? Planck and Einstein. Okay, later on. So this is also de Broglie equation. That is explained by de Broglie, and this is also called as, okay, later I will say. So this one, dual behavior of matter. Initially what I said, that is nature of matter explained by whom? De Broglie scientist. Okay, so this is small, this is capital. Next, second one leading point is, that is uncertainty principle. Example, uncertainty principle. These two are the main leading points for the development of quantum mechanical model. Okay, so listen, I am going to first dual behavior of matter. Okay, so first one. Okay, so students, this dual behavior. So one is the particle, another one is the wave. So that is explained by the two scientists. Einstein also explained the same thing. Okay, and also saying that Planck also explained the same thing. By considering the equations of both Einstein and Planck, so this de Broglie designed or introduced a new equation called as matter-wave equation, or it is also called as de Broglie equation. Understood? Okay. So this is derived by how? The combination of both Planck's equation and as well as Einstein's equation. Okay. So I'll check here. According to Planck's quantum theory, according to Planck's quantum theory, E is equal to h nu. Okay, so this is equation 1. H is the Planck constant, nu is the frequency. And this, you know that this equation, C is equal to nu lambda. So nu is equal to lambda by C. Understood? Or, sorry, nu is equal to C by lambda. Nu is here, that is C by lambda if you cross multiply. Correct? C is equal to nu lambda. So nu is equal to C divided by lambda. C is here, so lambda is here. This is the conversion. Initially, before explaining the Planck's quantum theory and the wave nature of the matter, I explained this. This is frequency, this is wavelength, this is speed of light. Understood? Next here. So E is equal to h nu, that is Planck's quantum theory according to. Next, according to Einstein. According to Einstein, mass energy equation. Okay, that is E is equal to mc square. Understood? So this is equation 2. So compare equation 1 and 2. And the left hand side E is same. So then right hand side we may equate. Left hand side is same, then right hand side is also same. So from our equation 1 and 2. Then what happens? H nu is equal to mc square. Correct? Next is it. Substitute nu is equal to C by lambda in equation 3. So this is equation 3. Understood? Next. So here H is there. What is nu here? This one. C by lambda. Are you getting? C divided by lambda. This is equation 3. I am writing here. Substitute nu is equal to C by lambda in equation 3. Where is nu here? Here. Here we have to substitute C divided by lambda. That is equal to what? mc square. Okay? The C and C gets cancelled. C square is there. 1C gets cancelled. So H by lambda is equal to mc. Okay, so then lambda is equal to h divided by mc. Are you getting? Just cross multiplying them. Lambda is equal to h divided by mc. So this is the de Broglie equation. And this mass into velocity is also, we know that mass into velocity is equal to momentum. P means momentum. That is also equation. Mass that is equal to momentum. So lambda is equal to h divided by p is also equation. These two are what? De Broglie equation or matter-wave equation. This derivation is important for 2 minutes. Just by comparing, you have to consider one the Planck's equation, another one Einstein's equation. Just you have to compare and you have to substitute mu is equal to c by lambda. Then you will get the answer. Okay, important for 2 marks. Understood? This is the equation. So first one, explain dual behavior of matter. Here listen, mass is also there. When mass is there, when it is in a particle form. Mass. For waves we cannot measure mass. They are like waves means of course they cannot be visible. They don't have any mass. They travel like this, right? Just like that. Understood? So here mass is there, velocity is there. Of course mass you consider. Understood? Mass is there means that explains the particle nature. Lambda is here. Lambda means what? Wavelength. It also explains wave nature. So both wave nature and the particle nature explained in the same thing. That is what? Nature of matter or the dual behavior of matter successfully explained by de Broglie by considering two equations of Planck and Einstein. Okay, this is the equation that successfully tells about nature of the matter. So first thing is finished. Second one is what? Einstein's uncertainty principle. What is uncertainty means? Uncertain means which is not possible. Certain means of course which is possible. Uncertain means which cannot be possible. So the Einstein was the scientist tells about the uncertainty between some relations or any two quantities. So the best one quantity here is one is the position and another one is momentum. One is the position and another one is what? Momentum. Okay, so what it tells about? So listen here. This is the nucleus. Electrons are revolving around the nucleus. So we consider position A here and position B here, position C here. We need to find out the momentum of the molecule at the position A. So listen, electrons are the fast moving species. They are revolving very fast manner. We cannot see them easily. So in the atomic radius, while I am explaining the definition, I told the distance between the center of the nucleus and the outermost electron cloud outside. I said not electron. I said electron. I used electron cloud. So means if the electrons are revolving, then they left a path where they are certain what is the sign from where they are moving. So when rocket is moving, it left a white color path, Of course we can justify, we can say that so rocket is moving like that. White color foam. Are you getting? So if anything is passing means they left their footprints backside for us. If we walk on the sand in seashore, our footprint will be there. Then we can easily justify. Of course, a human walked here. Similarly, and the same way, electron also leave their footprint when they are revolving around the nucleus. That is called electron cloud. Where the electron is not there, but the path of electron mode is there. Means the electrons are very fast moving. At this point, if you want to measure, this is the position here. And at this position, we need angular momentum means, or any momentum, spin or angular. So it cannot be possible to measure because the electron, not even a second, it is living. Means it cannot stand at least for a second here. Understood? It is very fast moving. So if you are trying to what is that, calculating angular momentum or spin angular momentum or orbital angular momentum. Two types of momentums are there: spin and angular. Angular means one which is revolving around this. Spin means one which is itself revolving, like Earth and Sun. Earth revolving it on its own axis, correct? That is spin. And at the same time, Earth is revolving around the Sun. Rotation and revolution, you know that. Okay, one which is revolving around the Sun, that is one which is revolving around the one axis, that is rotation. Similarly, the rotation of an electron is a spin angular momentum. The revolution of an electron is an angular or orbital angular momentum. Understood? So two types of momentums. So if we try to find out the momentum, then we cannot fix the position. We can easily find what is that MVR, angular momentum, is equal to h divided by 2 pi is the what? Formula. H we know, 2 is know, pi we know, mass we know. Okay. Next, R is the radius, V is the velocity. But here there is no position, there is no x value. Understood? There is no distance value here in the momentum. So when we measure momentum, we cannot measure position exactly. When we consider the position, we cannot measure momentum exactly. That is uncertain. We cannot simultaneously, instantly, at the same time, we cannot measure both position as well as momentum. That is what Heisenberg uncertainty principle. Uncertain means which cannot be possible. For what? For electron. Listen, I am telling. So this is only for those one which they are having. There is no mass. You know, electrons are not having any mass. So here there is no mass factor. Electrons are having only charge. They are not having any mass. I told you. If any 1 ton atom is there with a weight of 1 ton, assume, or at least 1 kg, we can easily measure its momentum, position, everything. Mass affects the angular uncertainty principle. If the lighter particles are there, uncertainty is more. If the heavier particles are there, uncertainty is less. Electrons they are having no mass, they have only charge, they are very light, that's why they are moving very fast. Are you getting? So for example, for this, a paper and a stone. So here we are having this paper as assume one piece of paper is there, wait. Okay, so this is one piece of paper is there, here pen is there. If I leave both this paper and pen at the same time, one which reaches very fast to the ground is what? Which one? Pen. Are you getting? So this is where lighter in mass, this is heavier in mass. Means, so this one very lighter means, so this we cannot, so this is very, means its movement is very less. Its gravity is less. So it is revolving very fast. Mass is very less. Okay, this one having heavy mass. So they easily reach us. Understood? We can measure their weight, we can measure their, what is their position, we can measure their distance, everything. Electrons, of course, we cannot see them, and they are lighter particles also. Their movement we cannot be. Then when we observe in the microscope, we can observe only the part where the electron is revolved. We cannot see the electron exactly. Understood? When we observe through the microscope, because they are microscopic particles. So then what we are going to see? Only the part where the electron is revolved. We cannot see the electron. Are you getting? So this is what uncertainty principle. The statement of uncertainty principle is at an instant time, it is not possible simultaneously to not possible to determine position and momentum of the electron simultaneously. This is uncertainty principle. So students, here position is represented by delta x and momentum, this is position, means changing position. Here is from here to here, x1 is there, x2 is there, x1 minus x2 is delta x. Next, similarly, momentum is delta p. There is an uncertainty value. How much? So this delta x into delta p is always greater than equal to h divided by 2 pi. H divided by 2 pi. This is the uncertainty relationship for position and the momentum. Understood? Understood? So these are the two things that are the key points for the quantum mechanical model of an atom. First one is real behavior of the matter, which is explained by the D Broglie, and he derived an expression that is called as D Broglie equation or matter wave equation. Second one is Heisenberg uncertainty principle that tells about that at the instant time or the simultaneously we cannot measure the position and momentum of the electron in the or around the nucleus. Okay, so considering these 2 points, they develop a quantum atomic model. So then, what are the postulates of this quantum atomic model? This is leading, and I am going to write postulates. Okay, so the first one is the energy of the electron is quantized. The energy of the electron is quantized. Next, the existence of quantized electronic levels are directly proportional to wave properties. Now, properties of waves. Okay, so this is also explained by Schrodinger equation. That is explained by Schrodinger's equation. Next, exact position and velocity of an electron cannot be measured. Cannot be measured. Next, fourth one, and atomic orbital, an atomic orbital is the wave function that is represented by psi, psi, psi of an atom. Okay, the atomic orbital is the wave function of an atom. Next, last one. The probability of finding an electron is equal to psi square. These are the postulates. Means here they said uncertainty principle and the wave nature both. Understood? So the first one is the energy of the electrons is quantized. Quantized means a packet of energy. They are reserved. That is called quantized. Quantized is explained in what? Particle nature. Understood? And at the same time, the existence of quantized electronic levels are directly proportional to wave properties. Understood? Means they exhibit both particle as well as wave nature here. The properties of these quantized electrons as well as these wave properties are similar. Understood? And the next one is, as I told you, uncertainty principle, position and the velocity of an electron cannot be measured exactly. Understood? Next, an atomic orbital is the wave function psi. That is represented by what? Psi. This is the wave function that is of an atom. And the probability of finding an electron, as I told you, where that electron is present. You know, the electrons are present in the s orbital, p orbital, d orbital, f orbital. That is the probability. In the classification I told what are s block elements. The last electron one which enters into the s subshell or s orbital. Understood? Those orbitals are explained by these. So these are atomic orbitals. What are those? S, p, d, f orbitals are the atomic orbitals. If the last electron enters into s orbital, s block element. P orbital, p block. D orbital, d block. That is what filling up of electrons. The atoms. Lithium, it is an atom. It is s block element. Carbon, it is an atom. It is p block element. Okay, and also the iron, it is also an atom. It is a d block element. Uranium, it is also an atom, but it is active, it's a block element. Understood? Are you getting or not? So means atomic orbitals nothing but what I explained, the SPDF orbitals. Those are what? Wave function of an atom. So and they are equal to psi square. As I told you, the number of electrons to be added in the shell is equal to how much? To n square. In the shell, that is. Means, as it listen here. So this is the nucleus. This is the shell. K shell, L shell. So K shell means 1s orbital. L shell means 2s, 2p orbital. 2n square is what? This one. How many number of electrons are to be filled in K shell? This is 2, this is 8. That is 2n square. So here the probability of finding an electron is equal to psi square. Means s orbital means that is spherical in shape. Later I will say p orbital is dampened in shape. So electron may be present here or here. In the p orbital, it is like that. Electron cannot be present here and here at the same time. Either it may be present here or here. That probability of finding an electron is equal to what? Psi square. This is the wave function if we observe in the different orbitals. Where the electron is present, that is equal to how much? Psi square. Understood? Just remember this. After explaining the shape and the different quantum numbers, their rules, and you are going to understand these 2 points. Understood? Initially, the orbitals are SPDF, remember that much? And how many electrons to be filled in the orbital and where they are present. That is what? Size curve. Understood? So this is all about the postulates of quantum mechanical model. So this quantum mechanical model further consists of four quantum numbers. One is principal quantum number, azimuthal quantum number or orbital quantum number. Third one is magnetic quantum number, and the fourth one is spin quantum number. So I hope you remember, students, in the explanation of the stable configuration and unstable configuration. For p orbital, I took three boxes like this. Understood? For d orbital, I took 5. 1, 2, 3, 4, 5. For s orbital, I only take 1. Okay? Why I am taking those boxes means this one, where the electrons are present in the orbital, explained by magnetic quantum number. You know, 1s2, 2s2, 3s2 we are going to write. Correct? 1, 2, 3 are the principal quantum number. Means these shells 1, 2, 3 where they are present. SPDF 1s, 2s, 2p, 3s, 3p, SPDF, those are our what? Subshells. That is azimuthal quantum number. Understood? Next, in SP3, sorry, 2p6, sorry, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. That is this one, magnetic quantum number. From which what is there? From where electron is there. How the magnetic moments are, sorry, magnetic quantum number is to be determined. Another one is there, I hope you remember. I'll write the one electron like this. If only one electron is there, I used to write like this. If another electron is there, I used to write like this. One is upward spin, another one is downward spin. This is spin quantum number. So one is plus half, another one is minus half. Understood? Okay. So this is all about the different quantum numbers. I'll explain in the tomorrow's class. That quantum numbers compared to these postulates in this quantum mechanical model, the quantum numbers and their significance is very important for 4 months and it is a compulsory question. Always they used to ask. And from tomorrow's class, it is so interesting. Still it is theory, from tomorrow it is like calculated. Understood? So in the tomorrow we will discuss about the quantum numbers. Thank you.